All right, we are going to review solving linear equations. And how we're going to do this is we're going to go from the very easy, very, very basic, very, I think, 6th or 7th grade to getting more and more challenging with each and every step, okay? Another step gets added on each time, which is fine because the process is always the same. What we're trying to do is we're trying to get the variable alone so that we can know what the variable is. I don't really care, like this says x plus 2 equals 14. Well, that's great. I don't care what x plus 2 equals. I want to know what x equals. X, give me x. I don't care what x plus 2 equals. So, and I'm going to do this by undoing everything that has been done to this x. Like what is being done to this x right now? Well, it has a plus 2 on it. So how do I undo a plus 2? Well, the opposite of addition is subtraction. So I'm going to subtract 2 from both sides. Now this is an equal sign, so it's kind of like a balance. If I subtract 2, then this one will be too light, so I have to subtract 2 from this one as well, or else they don't balance, right? So these two go away. So I end up just up with x equals, well, 14 minus 2 is just 12. So x equals 12. And I'm done. And I circle my answer so my poor teacher can find it, okay? So this next one, oh, we have something multiplied by the x and something added to it, and then we have it equal. But the first thing we need to do is we still need to get rid of the thing that's added first. We always start with the things that are added to it first. Well, the first thing we start with is actually combining any like terms. We don't have any like terms. We can't add 3x and 5. So we're gonna get rid of whatever is added or subtracted. The 5 is added to it. So the opposite of addition is subtraction. So I'm going to subtract it away. So we always subtract it away. The first thing we do is we either add or subtract. Depending on what's here, we do the opposite. So I end up with negative 3x, because the 5's go away, equals, let's see, 11 minus 5 is 6. So now I have a negative 3 that's multiplied by the x. The opposite of multiplication is division. So if I want to get rid of this negative 3 that's multiplied by the x, I need to divide by negative 3. And so I will end up with x equals 6 divided by negative 3. Well, 6 divided by regular 3 is 2. And a positive divided by a negative is a negative. So x equals negative 2. On this next one, we have an additional step. We have this x plus 3 in the parentheses, and it's multiplied by the 6. So I need to multiply this 6 and distribute it through. I have a 6 times x and then a plus 3. So 6 times x is just 6x. And 6 times plus 3 is plus 18. Equals 18. All right, so I have a plus 18 here. We're not going to worry about the 6 quite yet because we have something that's added to this x that we need it to not be added to this x anymore. So we're going to subtract 18 from both sides. So these two cancel, and I end up with 6x equals 18 minus 18 is 0. Okay, so now I have a 6 multiplied by the x. I don't want to have a 6 multiplied by the x. I want to have x be alone. So the opposite of multiplication is division. So I'm going to divide by 6. But if I divide one side by 6, I have to divide both sides by 6. So I'm going to cancel those out. And x equals 0 divided by 6, which is 0. So x equals 0. All right. Ooh, we've got x's on both sides and we have things being distributed. We can handle this, okay? So the first thing we need to do is get rid of these parentheses and distribute this 2 through. So we have 2 times x and we have 2 times plus 6. So 2 times x is 2x. Plus 2 times plus 6 is 12. Equals 4x plus 4. So now I need to get my x's together and I need to get my numbers together. I have x's and numbers on both sides. So I'm going to look at this, and my 4 over here is positive and my 2 over here is positive, and the 4 is bigger than the 2. So if I subtract this 2x over here, then I won't have a negative number. And I like not having a negative number. So I want to get my x's together. So I'm going to subtract this whole 2x from this side and the whole 2x from this side. So I ended up with 12 equals, let's see, I have 4x minus 2x is going to be 2x plus 4. So I still have that plus 4 sticking there. It hasn't gone away yet. And I didn't subtract the 2x. I wasn't able to combine those terms. I just subtracted it from the 4 and we're good. So I still have a 2x and a plus 4. Okay, so now I need to subtract, the opposite of addition is subtraction, so I need to subtract 4 from both sides. If I had 2x minus 4, I would be adding 4 to both sides, but I don't, so I'm not. So this equals, so the 2x just comes down now because we subtracted away those 4s. So let's see what happens with this 12. 12 minus 4 is 8, so I have 8 equals 2x. I'm kind of running out of room here, so I'm going to pop this back up here. 8 equals 2x. I still have a 2. That is multiplied by the x, okay? 2 times x. The opposite of multiplication is division, so I'm going to divide that guy away. 8 divided by 2 is 4. So I end up with 4 equals x. So x equals 4. These are all positive. Oh, no, that's a negative. Okay. So now, oh dear, I've got some pretty hairy fractions. Now, I really want these to not be fractions anymore. I'd be really happy if they weren't fractions. And the way, so this is 2 divided by x plus 3. If I don't want to have 2 divided by x plus 3, the opposite of division is multiplication. So I'm actually going to multiply both sides by x plus 3. Here I'm going to have x plus 3 over x plus 3, and they are going to cancel. And over here I'm going to have x plus 3 times the 4. And I'm not going to worry about this 3x minus 4 for a minute. Okay, so I still need to distribute this 4 to everybody, to the 3 and to the x. So 4 times x is 4x. 4 times 3 is 12. Over, I still have this 3x minus 4. We can't cancel things. We can't go, ooh, 12 divided by 4 is 3. It doesn't work that way, sadly. And then these guys cancel. So I just have 2 sitting over here. Isn't that lovely for a minute? But I still have this divided by that. And I really want to not have that fraction. So in order to get rid of the fraction, I multiply by the denominator. I'm going to multiply by 3x minus 4. Because the opposite of division is multiplication. So these are going to cancel. But what I do to one side, I have to do to the other. So 3x minus 4. So I'm still going to have the numerator here. So I'm still going to have 4x plus 12 equals, okay, so 2 times 3x is 6x. 2 times negative 4 is negative 8. So now I have this, and I'm once again running out of room. So I'm gonna move it up here. So 4x plus 12 equals 6x minus 8. So this last time, I thought about which one I was going to send to the x2 and which one I was going to send to the number 2. Instead, I'm just going to send the x terms to the left, and I'm going to send the number terms to the right. And I'm going to end up with some negatives, and we're going to deal with the negatives, and that's okay to have some negatives in our lives. Okay. So I have an x term over here that I would very much like to have be over there. It is added to the 8. I know that it's added because it's positive and there's an addition or subtraction sign between them. They're not multiplied and they're not divided. So I'm going to, since the 6x is positive, I'm going to subtract the 6x. A lot of people would think that the 6x is subtracted from the 8, but the 8 is subtracted from the 6x. That negative sign belongs to the 8, not to the 6x. The 6x has an invisible positive sign in front of it. So those two cancel. 4x minus 6x is negative 2x. I do have a negative number here, and that is okay. We can deal with negative numbers. Still have the plus 12. Nothing happened with the plus 12. But now something's going to happen with that plus 12. I don't want that 12 to be there. It needs to be over with its friend, the negative 8. The 12 as added to the 2x. So I'm going to subtract it away. If it was subtracted, I would add it. Okay. So now I have negative 2x equals, -8 minus 12. So I'm already 8 below 0, and I'm getting 12 more below 0, which is -20. So I have -2 times x. I don't want to have anything times x. The opposite of multiplication is division, so I'm going to divide both sides by -2. And I end up with x equals 10. Just regular old positive 10. Happy little positive 10. After all of that, x equals 10. How great is that? So let's do this one. Same process that we've always done. Same. We've got to distribute. So 3x. 3 times x is 3x. 3 times 4 is 12. Plus 12, because there's a plus sign and my 3 is positive. Equals 3x minus 15. Let's get the x's together. So I'm going to subtract 3 x's. I'm going to get this x over to this side. So I'm going to subtract 3x. Oh, dear me. There's a problem. They both cancel. And I end up with 12 equals -15. Well, 12 does not equal -15. On no planet does 12 equal -15. So this equation has no solution. There is nothing that x can equal that will make this true. Absolutely nothing. X equals 0, nothing. Okay, let's do the next one. 5x plus 15 equals 5 times x plus 3. So once again, I've got to do some distributing, right? Let's distribute. We're good at distributing after all of this. So we have 5x plus 15 equals 5x plus 15. Let's get the x's together. I'm going to subtract 5x. Oh, crappity crap. We're having the same thing happen. It's probably going to be no solution again, right? Well, let's see. So those 5x's cancel. Those 5x's cancel. We get 15 equals 15. Does 15 equal 15? Actually, yes, it does. Does 15 always equal 15? Yes. Will 15 ever not equal 15? Never. It does not matter what x equals. This equation will always be true. It has infinitely many solutions. You want to tell me that x is 5,621,000? All right, x is 5,621,000. If x is -3, if x is 2, if x equals pi, if x equals e, if x equals everything, then there will be infinitely many solutions. Every x in the known universe works for this. Even the imaginary numbers, they all work. All right. There are going to be some numbers that you're going to find when you have linear equations with. I was going to do some linear equation word problems, and I tried to figure out how to do this on this crash course review because we don't want to spend all day about it, right? So I thought let's just review what these words mean. Okay, less than. It does not mean x minus. What it means is minus x. If I say 4 less than a number, it's 4 less than a number. If I say 5 less than 4, 5 less than 4. Twice means 2 times. Twice a number. Twice 5. That's 2 times 5. Sum means add. The sum of 2 numbers is x plus y. Product means multiply. The product of 2 numbers is x times y. Difference is subtraction. The difference between 2 numbers is x minus y. We get into difference in slopes, the difference in the rise and the run. Quotient is division. The quotient of 2 numbers is x divided by y. More than means plus. Now I could say 5 more than a number, 5 plus a number. But because less than is on the tail end, I would rather have you write 5 more than a number, just so you're in the habit. Consecutive numbers go up by 1. 3, 4, 5. Those are consecutive numbers. So consecutive integers go x plus 1, x plus 2, blah, blah, blah. Okay. consecutive even numbers go up by 2 because you have like 2 and then 4. 4 is 2 more than 2. You have 4 and then 6. Well, 6 is 2 more than 4. So they're x, comma, x plus 2, x plus 4, blah, blah, blah. But consecutive odd, so we start with x, they also go up by 2. Let's say I have 1. What is an odd number? 3 is the next odd number. 3 is 2 more than 1. 5 is 2 more than 3. So they still go up by 2s, just like the consecutive even. That shouldn't be a plus sign. They still go up by 2s, just like the consecutive evens. It's just that they start on an odd instead of starting on an even. So they still go up by 2s, okay? And then another one that I didn't get on there is means equals. The same as means this side is going to be the same as this side, means it equals. So there's kind of your crash course on linear equations. I think linear equations can easily be the most challenging. If you go through the steps and you think, okay, why am I doing this? Do I need to divide? Do I need to add? Do I need to subtract? Do you think, okay, these numbers are multiplied, so I need to divide. Or these numbers are added, I need to subtract it away. You do not divide away the number next to the x if it still has something added to it. You just do not, because you have to divide everything by that number. So good luck, and let me know as usual if you have any problems. Bye.